Hey guys, this is 4.4, solving for x in an exponential and a log. Okay, I'm gonna pull out my 4.4 tricks and I'm gonna follow this flow chart. So to solve for x, first you figure out whether you have an exponential or logarithmic. An exponential looks like it has an exponent. A log has the word log. So let's look at our first example. 4 to the x equals 256. So this has an exponent. So I look at the exponential side. Now it says, can you use equal bases? That means, can you rewrite 256 as 4 to the something? That's what this means. Can you use equal bases? So for example, 4 squared is 16. 4 cubed is 64. Let's see if 4 to the something is 256. Let's try 4 to the 4. Oh, 4 to the 4 is 256. Woohoo! And that's what we wanted, 256. So the question was, can you use the same bases? Yeah, I can replace this 256 with a 4 to the 4. Let's do that. So I'm gonna have 4 to the x equals 4 to the 4. Now let's see what happens. Okay, so can you use the same bases? Yes. Rewrite as the same bases with different exponents. Yeah, my bases are the same. Big fat 4, big fat 4. My exponents are different. Tiny little x, tiny little 4. It says if you already have an exponent, nope, not me. Cancel out the same bases. So these big fat 4s cancel, and you just get the exponents. X equals 4. Hey, done with that problem. Let's try another one because that was too easy. Let's look at part B. We have 5 and 125. So the question is, can I rewrite this 125 as 5 with an exponent? So I know 5 squared is 25. Let's see what 5 to the 3 is. Hopefully it's 125. 5 to the 3. Oh, heck yeah, it's 125. So that means we're going to do the same thing we did on part A. We're going to cross out this 125 and we're going to write 5 to the 3. Now we have 5 to the 4x minus 1 equals 5 to the 3. And then now, since there's an equal sign between this and my bases are equal, I can cross out those bases, goodbye 5s, and I just have left over 4x minus 1 equals 3. And then we're going to finish it. Add 1 and you get 4x equals 4. Divide by that 4 on the x and we get x equals 1. Yeah. Okay, let's go to part C. The question is, can I rewrite these two suckers as the same base? Well, let me try making 243 maybe a 9 squared. Let's see what 9 squared is. Oh, 9 squared is 81. Let's see what 9 cubed is. It's 729. Poop. Okay, so I tried doing 9 squared, and that gave me 81, which is not 243. I tried using 9 to the 3, but that gave me 729, and I needed 243. So I cannot use the base of 9 anymore because it's not working out for me. So let's use something else. What divides into 9? What's the smallest number that divides into 9 that's not 1? So the smallest number that can divide into 9 is a 3. So let's try to rewrite this 9 and this 243 as 3 to some exponent. Well, 9 is 3 squared. Woohoo. And then let's see if 3 to the anything gives me 243. 3 squared is 81. 3 to the 3, nope, sorry, 3 squared is 9. 3 to the 3 is 27. 3 to the 4 is 81, but we want 243. 3 to the 5 is 243. So let's review this again. I tried to rewrite 243 as like 9 squared or 9 cubed, but I couldn't get it to be 243. So I looked for the lowest number that could divide into both of these, which is 3. Okay, so this 9 is now 3 squared, and then parentheses, the exponent that was already there, x plus 7. Then this 243 is 3 to the 5th, then parentheses, the exponent that was already there, x minus 8. Then cancel the same bases and bring down your exponents. So we have 2 parentheses x plus 7 equals 5 parentheses x minus 8. And then to get x by itself, we just have to distribute and sad map. So let's distribute. We're going to get 2x plus 14 equals 5 times x minus 8 is 5x minus 40. Then I get x by itself. I can subtract 5x and we get negative 3x. I can subtract 14 and we get negative 56. Then I divide by negative 3 and I get positive 1. This is not going to work out. Oh yeah, it did not work out. It's still dirty. I'm just going to say positive 56 over 3. So when I tried to put that in the calculator, it did not give me a pretty decimal. So I pressed math, enter, enter to get my fraction back. Okay, so this is all when the bases can be rewritten so that they can match and cancel out. Let's look at part D. Can I rewrite 2.95 as 10 to the something? Well, no, because 10 squared is 100, and I want 2.95. 10 to the 1 is 10, and I want 2.95. 10 to the 0 is 1, but I want 2.95. 10 to the negative 1 is, I think, 0.10, but I want 2.95. Anyway, so you can see that this ain't gonna work. So let's go back to our tricks. It says, do you have an exponent? Yes, I do. It's that x. Can you use equal bases? No, because this 2.95 cannot be written as 10 to some exponent. So, no, I do not have equal bases. Is your base a 10? Yeah, it is. That's a big fat 10. So yes, so it says put a log on both sides, log and the 10 cancel out. Okay. So we're going to put a log on both sides, log, log. And we get log 10 to the x equals log 2.95. And then there's a rule that says if you have a little baby's pretend 10 subscript and a big 10, they cancel out. Just like in the last section of notes, we had, let me see. Oh, we had log of 100. So we put in a subscript of 10. We rewrote 100 as 10 squared, and that canceled to just a 2. So same thing here. Okay, so that log 10 cancels, and we just get x equals log 2.95. And in your homework, this is what you type first, and then you put it in the calculator to get a decimal. So in your homework, there's 2 answers they want. The first with the LOG on it, and then the second with the decimal. Okay, let's look at part E. Is it an exponential or a log? Well, it has an exponent. Can I rewrite them as the same bases? No, I don't know how to rewrite 15 as a E. Okay, do you have a base of a 10? Nah, buddy, that's an E. So I'm going to look at the no part. It says put a ln on both sides of the equals. Use the power rule. Cancel out any ln and e you have. Okay. So I'm going to put a ln on this sucker. Ln e to the x equals ln 15.26. So if we have a number 10, we put a log on it because that cancels with tens. If we have an e, we put a ln on it because ln's have a subscript of a e, and ln e cancels, and we just get x equals ln 15.26. And this is what you would type in the first blank of your homework, and then you press enter, and then you type this in the calculator and get a rounded answer for your second answer. Okay, let's look at part F. Can I rewrite 23 as 2 to the something? And I picked up that 2 from my first base, and the answer is no, because 23 is prime. It's not even, so I cannot. So it is an exponential. I cannot use equal bases, so no. Do I have a base of 10? No. I have a 2. So that means you put a ln on both sides. So let's put a ln on both sides. But then something different happens here. The ln does not cancel because I don't see an e anywhere. The only reason it canceled on part E is because I had a e to the x. So this is not going to cancel. Well, let's use that one rule that says take the exponent and bring it down in front as a coefficient. Sorry, that coefficient is x. So when I bring it down in front, you get x times ln2 equals ln 23. Then to get x by itself, we're going to divide by this ln2. And we get x equals ln 23 all over ln2. And the ln is on top of the division bar, and the ln is on bottom of the division bar. So when I type this in to get a decimal for my homework, I'm going to type ln, it's the button beside the 4. So ln 23, close parentheses, divide, ln button 2, close parentheses, and hey, there's my decimal, 4.52, blah, blah. So make sure you type a ln for the top and the bottom.